We've seen a lot of these equations where it has an equal sign, but instead of having a whole number over here, it has two different numbers that maybe we're adding or subtracting or now multiplying. Our job here is we have to figure out what that really means. We talked about that these are like a balance. If we think of a balance, we have an object in the middle that's holding a lever with two things on both sides. We saw that if everything is equal on both sides, the lever stays perfectly still, doesn't move. But if I started adding more on this side, if I made this 12 into, say, 15, all of a sudden this side would tip just a little bit down, and this side would start going up because this side is going to be heavier. In order to keep it right in the middle, both sides have to be equal. That equal sign is like that little triangle in the middle trying to keep it steady. If we look on this side, these equations give us both sides of the equal sign, and we have to figure out if they're correct. The way to figure that out is to figure out what the total is on both sides. My first step is I'm going to figure out what the total on this side is going to be. So I know 7 plus 3 is 10, decimate 10 facts. I'm going to break down my equal sign, and now I have 6 plus 4. If I add 4 to 6, I'm going to get 10. Now I'm going to check if I have the same number on both sides. I have the same number on both sides, so that means that this one is true. Moving on to my one down here, I have 12 minus 6 equals 6 minus 12. My first thought is, well, those are the same numbers. They have to be correct, don't they? But then I think to myself, I know in addition and multiplication that I can switch numbers around and get the same answer. But subtraction's a little different. I have 12 and I'm taking away 6. So I know that's a half fact and that equals 6. But over here, I have 6 and they want me to take 12 away. If I had 6 fingers, I don't have enough fingers to take 12 away. So that means I can't do that side. So that means there's no way I can do that. So it has to be false. If the numbers on either side of the equal sign are not the same, then it's going to be false. Then they can't be equal to each other. 4 can't equal 7, can it? Over here, you have it on both sides, but now I have part of the puzzle missing, and I have to find my missing piece. Just like over here, I found the total on either side. The first thing I'm going to do is find the side that I have both of my factors or add-ins or my minuend and subtrahend. Here, I can see that I'm doing multiplication, so I'm looking for my factors. I see this side is the one that has both of my factors. So the first thing I want to do is I want to solve this side. So I have 7 times 3. If I think about it, that's really 3 groups of 7. I could do a doubles fact to help me. I could think of 7 times 2 equals 14, and then I have one more group of 7 to add, so it's 21. So now my new equation is going to be 21 equals 3 times something. 3 times something. I'm going to share it. I'm going to make 3 equal groups, and now I'm going to share this 21 until I don't have any left to give. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So now I have 1, 2, 3, 4, 5, 6, 7. Hold up! I could have done this way easier. I see 7 times 3 equals 3 times something. That's right. The commutative property tells me that I can switch the two numbers and still get the same answer. So as soon as I saw the 3, I know that I'm missing my 7 as a factor. But it's always good to check their work. Let's try this one down here. I have 8 plus 4 equals something plus 9. First thing I notice is this addition. I want to make sure I'm doing the right operation. Second step, I'm going to look for the side that has the 2 add-ins that I can add together. This one's missing one, so it means I have to look at this side. Step 3, solve the side that you have both your add-ins. 8 plus 4, I know equals 12. So it's 12 equals something plus 9. I only need 3 more from 9 to get to 12. So 12 equals 3 plus 9, so my 3 would go in my blank spot. Alright, let's do our last one together. For the side that has both the factors, I have 6 times 4, this is the side I'm solving for. 6 times 4 equals 24, so it's going to be 24 equals something times 12. Let's see. I remember that 12 as a double stacked in addition is 24. And 12 plus 12 is a double stack, but it's also repeated addition. I'm adding 12 2 times, so that must mean that 2 times 12 equals 24. So when we look at balances, we want to make sure that either side of our equation is equal to each other, that both numbers on either side of the equal sign are the same.